We're going to jump into this problem, well of ideas. It's a harder version of another problem called well of ideas. I'll go ahead and read it, and then we'll work through it like we normally do, understanding the problem, talking about different cases that the problem needs to handle, talking about instances of those cases or specific inputs we'll use to test those cases, and finally we'll refactor and submit our code. So here we go. Well of ideas, harder version. For every good kata idea, there seem to be quite a few bad ones. In this kata, you need to check the provided two-dimensional array, X, for good ideas, good, and bad ideas, bad. If there are one or two good ideas, return publish. If there are more than two, return I smell a series. If there are no good ideas, as is often the case, return fail. The subarrays may not be the same length. The solution should be case sensitive, i.e. good, all capital good, and good with some of the letters capitalized, all count as a good idea. I think I said case sensitive, case insensitive. All inputs may not be strings. Okay, so we're going to get an array including other arrays. We know that because it says we're going to get a two-dimensional array. So that's an array of arrays. Each internal array is going to have good and bad as strings using different ways to capitalize it. So it could be all capital or some capital or no capital. Then if there are one or two good ideas, return publish. If there are more than two, we return a string that says I smell a series. And if there are no good ideas, return fail. So we have three possible things we can return. The subarrays may not be the same length, and then we talk about that case sensitivity. So we're going to look at the tests here for just a second before we delete them. So we see that it's giving us an array with three subarrays. None of them are good, and therefore we get bad. Here we have 1, 2, 3 subarrays, and we see good in the first one and good in the last one, so we get publish. And here we have 1, 2, 3 subarrays with good and good again and good again. So there's three goods, and anything more than two goods, we see I smell a series. So I'm going to go ahead and delete those now, since we're going to write our proper cases, and I'll delete this. And we will get rid of that. Let's go over to Replit and sketch out our cases. So they've already laid out a nice message for us here. Well of ideas, harder version. That's exactly what I would put there. But we are going to go ahead and delete that, and we'll start with a sort of a blank slate of tests. So I think it's pretty clear what the problem is trying to do, right? We have an array. It has some subarray. It has something like that inside of it. If we see good one or two times, we return publish, I think it was. Otherwise, if it's more than two, we return I smell a series, and if there's none, it's fail. The last part we need to keep track of is all inputs may not be strings. So we might have to interrogate that idea a little bit. I'm just trying to think if there's something else that could count towards good that wouldn't be a string, but I don't think so. I think we'll just have to ignore or discard anything that's not a string. And then we could have more than one array in here, and it could be empty, or it could say bad, bad, oops, etc. And we would close that. So we need to go through all of the different subarrays. We need to count how many times we have good, disregarding the capitalization, and if it's equal to one or two, we return a certain thing. I think that's pretty clear. So let's talk about our first case. So here we go. Cases. Okay, our simplest case would be, it doesn't say that the array has to have anything. So we could have an empty array with no subarrays, right? We could just straight up have one top level array. Let's see, I'm checking to see if it will tell us if we'll guaranteed some subarrays. Check the provided two-dimensional array for good ideas or bad. So it does say, it seems to imply that we'll always have subarrays. So in that case, let's go to array. The case will be similar, but it will be array with empty subarrays in any number. So if that was the case, what would that look like? It would look like an array with, say, 2 arrays inside. And the answer we would expect is, I'm going to copy and paste here just to get this right. If there are no good ideas, which would be the case here, we want to return fail. So I've got fail. And I think it's pretty obvious that if we had however many empty arrays here, it doesn't matter, we're still going to get fail the same. Okay, another case would be array with non-empty subarrays with no good. I'm going to just call these goods. So that looks like a parent array like this, a subarray that has bad, comma, bad, and then maybe another subarray with bad. And here we expect the exact same outcome, fail. Another example of this might look like our initial array, and then bad, bad, bad. That's just one, and it's still going to be a fail. Now, we have this sort of sub-problem to be case insensitive, and we could introduce that here, or we could do, we could actually break that out into its own case. But I think what we'll do here is actually take this as an opportunity to abstract that away into its own helper function. So what I'm going to do is I'm going to write here a note for myself. Helper function to normalize case, where now we simply start over here, where a helper function is going to have its own cases, and this is all lowercase. Let's put this another way. We want a helper function to make all characters lower case. So what's that function going to look like? It's going to look like takes in a string, and if that string is all lowercase, all characters, and we'll do this in a word because we know we're just working with one word at a time. So all lowercase, what's that going to look like? It's going to look like bad. And if we get bad, we expect bad. And then another option is good. And if we get good, we expect good. Now just go with me for a second. I know it might not be totally clear what we're doing breaking into a helper function like this, but I think it will be clear enough in a second. Now our next one would be all uppercase. So we might get bad, in which case we want to return bad. And of course, our other example would be good. And we want to return good. And then we can say mixed cases as our last case. And that would be like they give us the example of good. And that one we would want to get back good, or bad, and we want to get back bad. Great. So actually let's stop here and let's write this function as a helper function over here. So you can call it whatever you'd like. We'll call it to lowercase, and we'll pass in our word. Now we have our initial describe block, but that's going to be for well of ideas for well. So let's actually change this message to well. And that helps me know that well is testing this function here. And I'm just going to copy the whole describe block. and paste this. Until we start working on well, I'm going to comment this out. And here I'm going to put 2 lowercase, where 2 lowercase. Now we go back to this, we copy our message here. It handles words that are all lowercase. 2 lowercase, and I take in good, and I expect back good. Go ahead and test that. Okay, I see that I'm testing to lowercase. It handles words that are all lowercase. Expected undefined to deeply equal good. And actually, this doesn't need to be deep equal. We can just change this to equal. So, as is often the case, we're just going to do return good. And the reason we do that is because we're following test-driven development, and that is all we need to make this particular test pass. Okay, great. I go to my next test in this case. That is going to be for bad, and we want to expect back bad. I run my test, and I see that does not work because we expect good to equal bad. So we can go ahead and return word. When word comes in all lowercase, we simply return the word. Okay, now I will copy this it block. We will use it for our next set of cases. Let me go back to my notes. All uppercase. So we go here. It handles words that are all uppercase. Easy enough, right? We do good, and we expect good. And then this one I will comment out. Let me go ahead and test that. Okay, so we need to use the string method called to lowercase, and we'll call that. Okay, I've got a typo here because I meant to do good all uppercase. Instead I used 2 Ds. Okay, that's looking good, and I will comment this out now. Now we need to make sure we change this to all capital bad. Great, and now we go to mixed cases. So I'm going to go back here. I'm going to copy it, and I'm going to go that have mixed cases. So we want to follow what we did there, which I remember was G with 2 capital O's and then D, which is that, or BA lowercase d. Let's go ahead and test that. All right, good. So we've now got ourselves a little helper function. Probably overkill since there's already this method to handle this, but good enough. We've written tests for that. Now we're going to go ahead and re-comment in our describe block for our function well, and go back to looking at our cases. So now we have array with non-empty subarrays with no good subarrays. Given that we have this, now we've got a nice helper function to help ourselves figure out any of these case irregular ones. In fact, we'll make this one case irregular like that. Okay, let's go to the next case in this problem. We have array with non-empty subarrays with 1 or 2 goods. Easy enough, right? We just give ourselves a really simple case here. We can do good, good. And here we expect to get, I believe it's publish with an exclamation mark. Or let me copy this one here to just use some data that we already have. And we'll add in good. And over here, I will add in good. And if this is the case, then again, we would expect to get publish. Now we'll do another case. We'll use this one here, why not, as our base. And then we will just add in, let's do a separate array, and we'll just do 1 good. Close that initial array, and we have publish. Okay, since that one's testing a couple different things, meaning specifically that it has 1 or 2 goods, we could of course break this case up into 2. So we test with 1 good or test with 2 goods. I'm okay grouping them together as long as we do enough tests to represent both of those things. We wouldn't want to do just these first two that both have two goods. All right, next one, and our last case, array with non-empty subarrays. In fact, let me just copy all of this. With more than two goods. And let's go ahead and copy this one here as our example. And all we need to do is add in another good. It's fine. And then let's copy this one here. And I don't remember exactly what we expect to get back, but we'll talk about it in just a second. And we'll just do it all in one array here. Let's do case irregular because we want to test that. Cool. And now I'm going to go and copy what we expect to get back. We expect to get back I smell a series right here. Let me go ahead and paste this in, minus the period. Okay, now I feel pretty good about the test that we've lined out here. I can't think of any other cases that we're not covering. Oh, yes, there is another case that we're not covering, of course, which is this last line. All inputs may not be strings. So we would do array with non-strings. And now you could be very detailed and do array with non-strings with each of these three subcases that do have strings, but let's just test an array with non-strings and make sure that we don't have any errors when we handle it. And we'll do discards non-strings, which I think is what we're supposed to do with these. So I'm going to take, I'll just take this one here. We're going to do one publish example, one fail example, and one I smell a series, but each one with at least one non-string. So we can do like 13. And here we expect publish. Then we'll go with a I smell a series example. In fact, I can just copy the whole thing, put it here, and we'll add, let's see, let's replace one bad and we'll make it a Boolean. Try some different values here. And then we need one fail, so let me take that. So you see I'm choosing to use examples where we're getting a publish, an I smell a series, and a fail as we test these non-strings. And here let's have another one and we'll just put an object inside of it. So cool, let's let us work with that. Now I'm going to work through these methodically, case by case. So the first one I'm going to work with is array with empty subarrays in any number. So I go over here my first it block. I paste in my message, array with empty subarrays in any number. I go back to my notes. I copy the subarray. That's what's going to go into our function. And then I copy what I expect to get back, fail. And a lot of the reason I do that is to avoid any mistakes. It is all about being methodical and working with some precision here. And then we will go ahead and run our tests. Now, every time it's going to run the tests to lowercase. And of course, we expect those to be green and stay green since we've already done that. And then we say expected undefined to deeply equal fail. Well, folks, first time we just go with the easiest thing, return fail. And we'll go back to our tests. Wonderful, passed. We'll go to our next one. Okay, I'm just going to copy this. And here I do assert dot deep equal. Now what deep equal does is it looks inside of any subarrays. I'm pasting my argument in there, and then I will copy fail here. It looks inside any of our subarrays to make sure that the values are the same after all. Let's go ahead and test that. And that also fails, and it should fail, so we've got a working solution there. Move to our next case. I'm going to, actually, before I copy that, let me just copy the whole it block. Let's give ourselves some breathing room here. Put a space there. make a new line there. Copy this whole block here. Paste that in. Go ahead and delete this, and we will copy our new message. Like that. Paste that in there, and then go to our, we've done so much of the work already laying out our examples that we just have to kind of copy and paste and copy and paste. And this is going to go right in here as our argument. And if I'm not mistaken, we're expecting fail. So let me comment out this second test because we always want to add one test at a time. Looks good. It's failing as we expect. Go to our next one here. Comment this back in. And it should fail, and we go ahead and run that. Okay, we made a little mistake here. Looks like it's a mistake in our test. So let's see what we did. We did not close our array and subarray. I must have, when I copied, I must have missed the last bracket. Yep. Okay, we move to the next test block. Now, it may seem weird that we haven't written any code yet. We just don't need to write code if our tests are passing. Another way I like to think of this is, imagine that this function was going to take in 100 different inputs, and imagine if half of those inputs were covered by these two cases. Well, we'd have a 50% working solution, even with only writing literally 2 words of code. That is clearly, we're clearly going for 100% success, not 50%, but we also don't want to get bogged down in code when we can be solving essentially many cases with very little code. And as we do, of course, we'll get into more complicated code to solve all the rest of these cases. All right, here we have array with non-empty subarrays with 1 or 2 goods. So here we got it. And, you know, often I add in handles just so it reads better. It handles array with non-empty subarrays with 1 or 2 goods. Notice the good is in single quotes, so that should be fine for us since it's all wrapped in double quotes. Oops, typo there. All right, assert dot deep equal, calling well. We're going to get our argument right now. Well, here is our first argument. An array with a subarray with 2 goods, and we expect it to equal publish, exclamation mark. So we'll always run our test first. What do you know? It failed. No surprise there. So let's see what we need to do to make this one pass. Well, the first thing we can do is iterate through our subarrays. So let's say start by iterating through x. Now you might think x is not very descriptive, and I just want to point out that there's nothing at any point that says we couldn't take away x and call this something like, let's call it parent array. To me, that's initially a more descriptive idea where the parent is holding all of the subarrays, but you could call it what you want. So let's do that. Start by iterating through the parent array. Then inside the parent array, we'll need to iterate through the child arrays. And as we do that, let me drop down a line. We need to check if the value equals good. If it does, increment count of good. Then, so that we don't go too, oh, actually that's where we want to be. Now we know that we set up our helper function here and we need to put that in first. So let's go ahead and add that here. Process value with 2 lowercase value. check if value equals good, increment count of good, and then I'm indenting here because these are going to be put inside of loops. So when I say we're going to iterate through something and I'm doing these things inside of that iteration, I put them all in here. Now, I'm referring to a variable that we haven't created, increment count of good. So I'm going to go back here and I'm going to do let count of good equal 0. All right, now if count of good is, now we want to say if it's equal to 1 or 2. So how about if we say if count of good is less than 1, fail, otherwise publish. Exclamation mark. Now, of course, this is not ready, but if we follow the rest of this, we should be able to use this line to pass our test here. So I made a comment here, but that's actually just code. We'll write that one right in. We're going to iterate with a plain old for loop. For let I equals 0, I is less than parent array, I plus plus. I'm going to make sure that my closing bracket actually is going to go down here after all this code. Iterate through the children array. Okay, for let j equals 0. J is less than parent array I dot length. And we iterate by doing j plus plus to get every value. Now same, I'm going to go down here and put my closing bracket right there. Process value with to lowercase. So our value is parent array I, j, and let's set a variable. We'll call this good. Let good equals this, but of course we need to process it with to lowercase parent array. Now, check if our value is good. If our variable good equals the string good, increment count of good, we'll say count of good plus equals 1. Okay, so you can see I just really followed along with my comments. Don't worry if this takes you longer to kind of think through a problem like this. It just comes with practice that you get faster and faster. All right, now, of course, you'll notice, I think, that if we go back to the instructions, we haven't even touched the case where we say, I smell a series. But our test hasn't told us to handle that yet, so we're just not worrying about it. We're only worrying about the test that we have here. We want to make sure we haven't done anything to ruin our first test that we set up for to lowercase. Of course, we haven't touched that, so I don't know why it would. We want to make sure we're still passing our initial test that we wrote, and we want to make sure we're passing our new test. So I'm going to go ahead and run that. Okay. Expected fail to deeply equal publish. So it seems to me like we did not get to publish here. So let's talk about why that might be. Count of good is less than 1. Count of good equals 0. Count of good this. Oh, I see. It looks like I've got a typo here where I tried to do 3 equal signs, but I put a minus. Let's go again. Okay, it still didn't work. If good equals good. All right, let's make sure. Of course, it can be tricky navigating arrays inside of arrays. So let's look at that first. We iterate through our parent array. Oh, here we go. We need parent array dot length, not just parent array. Here we do have length. We remembered it there. I remembered it there, but I forgot it up there. So try that again. All right, looks like we're good. So we look for our code, debug, look for typos. We've got this nice roadmap here telling us what we're doing, and we are good until there. Let's go ahead and copy this, paste it, and I'm back to my notes, and I'm on to my next case here. You notice I don't even really think about the cases once I've already laid them out. I think about them when I'm writing them, but once I'm on to solving the problem, we just know that this is the case and this is what it's supposed to do. Go ahead and test that. Now, the way we wrote our code, it solved both of those cases, so that's perfectly fine. We've got one more here. And I did not copy it this time, so my bad. Let me paste that and then recopy what we had over here. And make sure I go from parenthesis to parenthesis. Great. Test that. We are looking very fine. All right, copy our it block, paste it again. I'm going to delete all but the first one because obviously I'm going to overwrite it. And I don't like to get my things muddied up or confused. I'm going to go ahead and delete the message in here because we're about to put in a new one. And we're going to delete our cases because we're going to put in new ones. And we're going to delete that. Whoa, too much. We're going to delete that because we're going to put in something else there. So I'm back to just a very basic it block here with no values. Moving on to our next case, I'm just going to go ahead and copy this. And that's going to go up here in our quotes. It handles an array with non-empty subarrays with more than 2 goods. Okay, so let us just copy this. And paste that in. And then we could, of course, we could just copy from the instructions here. Probably better to copy from the instructions, and especially if we didn't copy the first time. That's what we want to return. And it goes here. Okay, we'll go ahead and run that test. Okay, awesome. Our first 3 it blocks. You notice that each one of these arrows corresponds with an it block. We've got 1, 2, 3. We're on to our 4th. And sure enough, we see our 4th expected publish, which is what it actually returned, to deeply equal I smell a series. So our logic right now is if count of good is greater than 1, return fail, otherwise publish. But we need to be a little more detailed in our logic here. So we could either set up like an if statement, or we can set up a double ternary, which I think is what I'm going to do here. So if count of good is less than 1, fail. Otherwise, if count of good is less than 3, publish. Finally, give us I smell a series. And just so we can be, I don't know, overly uptight, let's go ahead and change these to all single quotes for no good reason. It really won't change anything. So when we get to count of good, assuming we have the right count, if it's less than 1 or 0, why not change it to 0? Be more explicit. If it's equal to 0, fail. Otherwise, check it again. If it's less than 3, so 1 or 2, publish. Looks like we've got one extra quote there. Otherwise, I smell a series. Let's go ahead and test that. Okay, we've got a typo here. Oh, we've got another extra quote there. Annoying. Okay, and we're looking good. Looks like it's passing our last case as well. Let's go to our next input. So I'm right here, and I'm just going to type it out. Assert dot deep equal. Well, paste my argument in. Comma, and I will copy from here, paste that in, and test that. Looking good. We're passing that one too. I think we just have the 2 examples in that case. All right. Now we need to move on to our last thing we need to handle, which is arrays with non-strings, that it can work through non-strings without choking or something like that. So we'll type it from scratch. It handles arrays with non-strings. Now we might want to be really detailed and say handles subarrays with non-strings. And I'm not going to do discard. That's fine. Plenty descriptive like that. Okay, and we've got assert dot deep equal well with our argument and expecting, what are we expecting? Let's go back here. We just copy this. So I've got more than I bargained for here. There's our input. And what do we want to return? We want to return publish. So let's go ahead and run that. Now, I run it, of course, to see if my test is written properly, but a big reason I run it is to, because sometimes we've already written code that will pass an extra case, and if you have, that's totally fine. It's always our goal to write just enough code for the case that we're working on, or refactor to pass the case that we're working on, but inevitably sometimes that will result in solving another case. All right, okay, so we've got a problem. Word.toLowercase is not a function. Well, why is that? It's because toLowercase is looking for a string, and we've now passed it in an integer. So somewhere before we call that here, we need to make sure that things are a string. So let's add in a step here. Verify that value is a string. So, simple as if parent array I, j, and we can use the type of, and then is not equal to a string. It's a pretty simple vanilla way of checking if something is a string. So we say if the type of the value is not equal to a string, then let's just continue. We'll just keep going in the loop to the next one. Let's go ahead and run that. Okay, now we've come to a problem in the actual test itself because I did dep equal, like it's Johnny Depp, and we need deep equal. So let me run that. All right, looking good. Now we still have 2 more cases to handle for our test for non-strings. Assert deep equal. And I need to get in the habit of just copying and pasting even more than I currently am doing because it saves time, but more than saves time, it eliminates mistakes, and that is what we're all about. Here is our expected value. I'm going to go ahead and run that test. Looking good. We've got that working. Whoops. Go ahead and paste in another assertion. Go ahead and copy my example array here. Again, it takes some precision to know that we're copying and pasting in the right places, but a lot less than it takes to type everything correctly all over again. Put this in here, and I go to test. Okay, looking good. Now I've tested all of the cases that I could think of. I've got empty arrays in empty subarrays in any number, array with non-empty subarrays, handles array with non-empty subarrays with 1 or 2 goods, handles an array with non-empty subarrays with more than 2 goods, handles subarrays with non-strings, and then we've got our little tiny helper function here, which is probably overkill, but we're going to go with it. I'm going to test one more time. I always over-test before I submit a solution because once it's done, it's done. So let's go ahead and attempt this. We've passed on the first time exactly what we want to. We've got random tests here, they passed. We've got testing for fixed cases, they passed, and we can be happy with ourselves that we worked through all the cases, we thought of everything before we even clicked on submit. Now, I'm going to delete my comments like I usually do. You guys have seen me do this before. I just like to clean up my code. The comments I think are great scaffolding, but after a while we have found our solution, we don't need them. And I'm going to separate out a couple of these things. I like to have just a little bit of breathing room in the code. This is too much, one line is fine. Here's our solution, and I run my tests again. Whenever I'm refactoring, even if I'm just taking out comments, I'll always run my tests again to make it work, and then I'll go ahead and click on attempt. Fine, move on to submitting it. Looking very good. Now we'll look at a couple solutions here. Let match equals an empty string plus the array dot match, looking for this of good. So we've talked about this in class before, but this is using a regular expression, looking at x, matching it with a string, and then using a regular expression to find good in it, and then just looking at what match, the count essentially that match was able to take. If match.length equals 0, fail. Otherwise, if it's less than 2, publish. Otherwise, ISML series. If you want to do a solution like this, you'd want to hone in on what is match and what is a regular expression. You could make that work. Here we have x for each. So this is the top level loop. And then inside an array for each, this is the interior loop, similar to what we did. If the type of the element is a string, well, yeah, we had that, and the element to lowercase equals good, then increment your count. So this is extremely simple or extremely similar, not simple, but similar to what we did. If count equals 0, return fail. Otherwise, they have their ternary here for these two. We're just going to look at those two. This one's pretty different than what we did, but relies on a different approach. And this one's very similar to what we did, just using different methods. And that wraps up this video. Thanks so much.